All right.
Mr. Justin Anderson,
All
USDOT.
right. Hey. Thank you all. Yeah, thank you for coming to this to Plugfest. Today my name is Justin Anderson. I lead the next generation wireless communications project and the secure credential management projects at the ITS Joint Program Office. So I'm also, for those that don't know, I'm known as the technical guy at the ITS JPO. So I'm the guy that understands how all this stuff works probably a more technical level than most of the folks in my office do. So I get to do this cool stuff. And for those that know me, this is what I love. I love the engineering stuff. I'm an engineer. I love being an engineer. I love talking with other engineers. So today I just want to talk to you all about sort of a lot of things that are going on. Obviously, there's a lot going on in V2X. I want to give you some updates on some key things and then talk about some of the things that I'm specifically leading that I think are also helpful for sort of the full community. So we'll go ahead and get into it. So talk a little bit about V2X deployment plan. FCC update. Unfortunately, I can't announce a second reporting order yet, but I think it's close, so I'll talk about that. And then last thing is interoperability testing. I've got a pretty big update there. So at any point, if you have questions, feel free to raise your hand, or if you want to save them to the end, we can talk at the end as well. Totally up to you all. So for those that, I'm pretty sure most of you all are aware, we released our national deployment plan in August. I think what's important for folks to understand is this plan was signed by Secretary Buttigieg. This is a full DOT plan. This is not like a FHWA plan. This is a Department of Transportation plan. So it also means that we actually have to track against this plan now. So for those that don't know the seriousness of that, it means all of the targets, the things that we list in this plan are all things that now my office is figuring out, what are the metrics we need to capture to start tracking our progress against these goals and things like that. So this is actually a very serious plan that it's signed by the secretary. So it's literally committing the Department of Transportation to deploying V2X. So hopefully that makes everybody happy. And it definitely makes those of us that have been here for a while doing this happy. For those that don't know, I've been doing this for close to 20 years. I was part of the Booz Allen team that helped build the VI testbed in Oakland County, Michigan. So I know Randy, some of the other older faces from 20 years ago. So it's great to see you all that have been here that long. And so I'm very passionate about V2X and really am happy that we've been able to put out a government, DOT sponsored plan. So I'm not going to read all of this overview, but for at a high level, right, we laid out some, I think, aggressive but realistic targets for where we want V2X deployments to go. We have short, mid, long-term goals. We have, resources and technical assistance. The interoperability testing, I think, falls within that. Another one that I think we haven't talked a lot about yet, but we will be in the future because we just kicked the contract off at the end of September, is an interoperability connectivity help desk feature. It's sort of our friends over here from the SIL, Leidos. We're sort of beefing up the CV equipment loan program to provide more technical support so that folks' deployments can submit tickets. And we have, we'll have different tiers of service, sort of like a help desk, just sort of somebody that can point you to resources. We'll also have the ability to escalate that to a tier where we get on phone calls and talk through things. And then a final tier of actually sending folks out to your location to help you troubleshoot problems. So that's something, again, we're proud of. We're also going to try, this is not always successful in the government, we're going to try to create some resources for folks, for the deployment community to sort of collaborate technically, sort of like a Reddit-ish, not Reddit. Obviously, we don't have the resources to sort of rival Reddit, but something like that, like a technical forum where folks, like the engineers, can come together and actually troubleshoot, talk to each other. We're going to try and make that happen as part of that. So there's a lot of aspects to this plan. And there are a lot more technical resources, implementation guides and things like that in development right now. So you'll see more with that. This was something I really wanted to highlight to all of you, V2X certification. This is all from the plan, right? This is what all of our leadership briefs. So V2X certification, trust and credential management, cybersecurity, wireless technologies, all this are sort of the keys, right? And so I see folks all across this effort in this room, and that's really what it's going to take. I try and talk to like some of the folks in my office about this. You know, the V2X stuff, the executing is in the details of this, right? Like there are a lot of aspects of this that are very tricky. There are a lot of aspects where there are things that are sort of a little bit open to interpretation that can change how things work operationally. And so, you know, all of us coming together, working through those issues, and deploying, a nationwide system, it's going to take all of us together. So, you know, I just want everybody in this room to know that, like, at least from our ITS JPO office and FHWA, like we understand that you all are a key aspect of making this work, right? We can't do this without forums like this. This sort of plug fest, you know, getting everybody together, working through these devices, making this technology work at a technical level is really the sort of the linchpin to making this whole thing work, right? So I just want folks to understand, like these two slides, and that's really what I want to get across, is that you all in this room are a critical part of this process, right? You can see these are all of sort of the high level stakeholders, but you know, again, you'll see, you know, credential providers, you see, you know, the standards test certification providers, right? Everybody, you know, the detailed technical aspects of this are in this plan. And are identified as sort of the keys to making it happen. So I just wanted to give everybody, you know, the feedback that you all are a critical aspect of this. And I know, you know, there's a lot of flashier events, ITS America, things like that, where, you know, ITS World Congress. But these are the types of events that I love because it's really engineers coming together, making this stuff work. In like a room like that next door, that's sort of always my dream, is a bunch of like test workstations working out technical problems. That's the sort of stuff that I love. So again, just want everybody here to be aware that you all are a critical part of making this V2X deployment plan happen. So FCC update. As most of you all know, the second report in order is in circulation right now, which that means is that the commissioners vote offline individually. So there's not a specific date at which they have to vote, like an open committee vote. There are some regulations around circulation about when a certain number of commissioners vote, the rest of the commissioners to vote. So we're actually working with NTIA and FCC to figure out, you know, how that is going to work for this vote. I will just say that from all of our discussions with FCC and NTIA, and we've been meeting monthly at a minimum since January of this year. The impressions that FCC have given us are that there are no issues with sort of this vote going forward. None of the commissioners have pushed back against it. It's just the process of getting through all of these commissioners' votes and getting the second reporter out. So it's still in the voting process. There is at least one commissioner that hasn't voted yet. Don't know exactly the total number that have or have not voted. But once they all do vote, unlike in the normal process where they will vote in an open committee, this second report in order will go straight to the Federal Register, and then it'll start the usual 30-day comment period and then a 60-day reply comment period for the FCC. So we're hopeful that will happen soon. Again, I can't give you a full date. The only other thing I did want to mention, though, is that the FCC did announce that they are planning to open Uni 6 and Uni 8 to VLP devices. For those that haven't been following the spectrum closely, we did a lot of research that showed that VLPs, specifically a VLP in a vehicle, acting as sort of like a hotspot and using a Wi-Fi channel directly adjacent to 5.925, would cause some interference issues for that specific vehicle. The good news of opening Uni 6 and Uni 8 is that the VLPs now have over a gigahertz of continuous spectrum to use for their communications. And so we will be doing analysis to show how likely it is that you would be forced below 6.105. But I think intuitively, the odds of a vehicle in the middle of a road being forced below 6.105 is probably pretty low if there's a gigahertz of Wi-Fi spectrum available above them. So that's the other piece.
Yeah, just had a question. still going to change of guard regardless because there will be a new administration
Yep.
in January 20th. How far could we potentially expect? Would it be safe to say we expect the federal, the RNO to be published, but maybe the comment periods still be pending, or
Yeah, I mean, I think everything we've heard is that it's likely coming in the next few months before the end of the year, hopefully. I can't tell you specifically because we don't we talk with the engineering office. We don't get to talk with the commissioners. So I can't tell you exactly how many the commissioners have voted, but yeah, everything we've heard is that it's coming likely before the end of the year.
okay. Because the commissioners, I think some of them maybe change
Right.
come January.
Yeah, when the new administration starts, there's always potential. Yeah, so the hope is that it gets done before then. Again, I can't guarantee anything. I don't get to vote myself, but that's the hope. That's what we've been hearing. We haven't heard anything to say that it's going to slip beyond that yet.
Is the VLP channelization, is that frequency hopping between that 1 gig, so they basically find an open space and
I think it's mostly Wi-Fi. Honestly, it's
So
even
that fixed
it's sort of like a VR headset or an AR headset. I think is sort of the main use case we were most worried about. Like somebody has a high like a Wi-Fi hotspot operating in Uni 5 and somebody has using an AR headset or like a Vision Pro, right, something like that in the car, and that's riding on that channel. That's what we were most concerned about. Again, I don't think it's. I think opening up Uni 6 and Uni 8 makes it extremely unlikely that that would ever happen. But I guess we'll see. What we're going to do the analysis to figure that out, though, or at least try to. Any other questions? I wish I had better answers here, but unfortunately I don't. The big discussion topic for today that I did want to talk to you, because I do have a lot of control over this one, is the interoperability testing. So I'm going to go over a little bit of an overview of what the type of interoperability testing I'm talking about, a short roadmap for sort of where we're going with it, and then I'm going to want to talk about the Wyoming interoperability test results that we did a couple weeks ago. Some of the folks in this room were there, so if anybody wants to chime in with anything that they saw, feel free. The interoperability testing that I'm talking about, the USDOT leading, is really focused on sort of operational deployments and configurations of equipment. So we were the testing, and I'll talk about in Wyoming, and the future testing. We're doing it in conjunction with operational deployments. And the idea is to use production certificates in devices, use operationally configured RSUs and OBUs, and use the same sorts of tools to generate messages, the infrastructure type messaging, as the actual deployments are using. Right. We want it to be as much as close to operational as we can, and really the goal here is to use that testing to identify ambiguities and gaps in standards and implementation guidance. I know a lot of folks in this room work in standards. I've worked in standards for a decade. It's we do our best, but it's not perfect, right? There are sometimes elements that are open for interpretation, and that's what sort of leads to interoperability issues. And so this testing is really meant to proactively find those issues, and then fix them. So the way we're going to fix it is we want to develop some short-term best practices to help deployments today, to help them figure out how to do it so that they're all interoperable with everybody else doing it today. And at the same time, give that sort of guidance to the standards and have them cement it through the standards, sort of consensus standards process, right? That's sort of the goal here. And really that's so that the Omnier testing here can cover, right, that functionality. And so when we get into TIMS, you'll see a lot of the guidance, that we want to create is something that just there are no standards that touch on it, right? They're very much, the TIM message, and I know the SPAT message had that issue. I know the CTI 4501 effort has helped clarify that somewhat. But there are a lot of messages that have a lot of optional elements, a lot of elements where there are room for interpretation, and folks have interpreted them differently. And so, and I'll be honest, like the reason we came up with this test is we have been hearing a lot of those things anecdotally, but you can't really fix things with anecdotes generally. So we want to use this interoperability testing to get the hard data so that we now have the evidence that it is a problem and we can go fix it. And again, I'll give you some examples of that in a little bit. So again, it's really this interoperability testing is really meant to sort of go hand in hand with OmniEra testing. For those that weren't there, Randy and Ryan were actually at the Wyoming interoperability testing, so they participated. We plan to keep inviting them and having them come and participate at the future ones as well. But really, we want to have about 4 of these over the next 2 years. We had our first one in Wyoming, October 7th through the 10th. Our next one will likely, I think, be in April or May. Kind of depends on what we want to do, scope, and the location that we want to have it in. Again, similar to the Wyoming testing, we want to try and have these tests in conjunction with locations that are deploying the equipment. I think the spring test, we might do some signal phase and timing or some intersection related type use cases, in which case we'll probably need an environment where we can shut down an intersection. So that one might not be completely operational. We might have to use somebody like a M-City or Swery, or, I know there's a lot of test environments that provide that ability to do that type of testing. So we'll work with the community to figure out where we want to have the next one. But likely after that, fall of 2025, then maybe spring of 2026 would be another of the 4th one. So roughly every 6 months is what we're sort of planning. And all of the planning is conducted in an interoperable technical working group I lead. It meets every other Thursday at 2 p.m. Eastern. When we ramp up towards an event, then we'll start meeting weekly. But if you are interested in joining, please email me. I'm happy to add you. It's open to everybody. It's a pretty, I think it's a pretty interesting group. We don't just talk about interoperability testing. We're also going to talk about other interoperability things that come up, issues that folks find in the field or encountering in their deployments. So it's sort of a broadly interoperable discussion in that working group. But that is also where we specifically plan for these tests. So again, if you want to join, please reach out to me. Please email. And now I'll talk about the Wyoming test. Again, we conducted this testing October 7th through the 10th. This was in the Archer facility in Cheyenne, Wyoming. It's about 10 miles to the east of Cheyenne. So this was just a big oval. I think it's about a mile.
1 mile diameter.
Yeah, 1 mile diameter. So the oval was over a mile, but it was about a mile here. So if you wanted, as Randy pointed out, if you wanted to get your certificates to change, you had to sort of drive over here a little bit, over to the right, off onto this. There's like a dirt road over there, and that was the only way you could get far enough away to get the signatures to change. But generally, we had 3 different TIM messages that were running during our tests. We would have a weather warning, which was just a snow warning. It was good in both directions. Then we would have a work zone TIM down here, which would start off with a advisory speed warning, into a lane change, into a regulatory speed change, into a work zone warning. And then we had a variable speed limit up here, and it would change from 55 to 45. And so the directionality for these messages was only good sort of if you were traveling counterclockwise. So you would only get the work zone in the variable message TIM if you were going counterclockwise. If you went clockwise, you would only get the weather warning. So we wanted to test directionality. And then in the middle here, we had some testing that SIA set up based off of some of the use cases that they do at the Hillsborough Expressway Authority. This is an end of ramp deceleration warning, and there was an RSU right here with a camera attached. And so if there was no car parked like right here, then you would get a short queue warning. And then we would do that for about a half an hour. And then we would park a car here, and it would trigger the RSU to change the TIM warning to a long queue. And really what it just meant was you would get a warning for, deceleration to like 40, 30, 20 miles per hour. And it would just change the locations of when those warnings came up. And then the last test we did was with a pedestrian warning. It was just the same RSU and camera setup. It would just be created a fake crosswalk here, and if somebody stepped near the crosswalk, it would trigger a pedestrian warning. The RSU would send that off, and then the vehicles would get it that were driving by. So how we laid out this testing is, and this is what you'll see in our test report when we produce it, hopefully here in a month or so. We have the RSU models. We used multiple models of RSUs. This row of numbers here is the RSU TIM table index. So these were the index that we put the message into. This was the weather warning, the variable speed limit, and then these combined made up the work zone TIM. So this was actually two TIM messages. It was the advisory speed warning and the regulatory speed change, and then the lane change, and then the work zone. And so the general way this worked is we would send out the first message that it didn't have an end time. It would just be good for as long as it was broadcast. And then we would update the variable speed limit from 55 to 45. And then we would add the last one, the V2 here, and V3 for this one, V2 for the rest, is we would update the message, and we would change to add a retirement time. So this red time was the retirement time. So here, we would start broadcasting the message at 8 o'clock in the morning. At 9 o'clock, we would add the retirement time at 9:15, and then we would keep broadcasting it for 15 minutes longer, so that if vehicles did come, we could check to make sure it still respected the retirement time. And then the testing went along, and you'll see this in the test plan and the test report. We started doing slightly more complicated things. We would set the message count at 127, and then update it so that it'd have to roll over to message count 0, since 127 is the highest number in the message count. And then we would also do things like we would broadcast V1 and V2 at the same time to see how devices would interpret it. An RSU that was broadcasting both. We feel like both of those conditions are probably fairly realistic in operation. Somebody's going to fat finger something sometime, right? Somebody's going to forget to retire a message, or put out a new message without revoking the old message. Those are the types of things we wanted to see how the devices would perform, right? And there's nothing in any standard about how to handle those situations, right? So we were just generally sort of interested in how the devices were processing that information. So a couple other notes about the data collection is we did create some sheets that sort of had this format, and then listed like, I got this message, I got it at this time. Essentially notes for each team that was running the test to give us sort of their handwritten results. And then we're also taking data logs, PCAPs from some folks of the data that they collected. And so the forms will be reflected in the test report that we produce, in all the data that we collect, the PCAP and everything else. We're collecting it in AWS S3 bucket right now, but it'll be posted to the ITS Data Hub eventually when we get all the data in. So what did we find? We found a lot of really cool, interesting stuff. We did find a few things that broke interoperability. There was one of the deployments that actually used the further info ID element in the traveler data frame. Most folks it's a choice in the traveler information message. You can use further ID info, or you can use road sign ID. Everybody but one chose road sign ID. But there was one set of devices that really didn't like the further info ID, and actually we could tell it received all of the messages, but didn't actually display any of them. And when they looked into their device, they figured out that once it hit that further info ID field, it didn't really know what to do, so it kind of just threw away the message after the further info ID. So that was an interesting finding, something we can provide some guidance around, I think, in some best practices documentation. Directionality and messages also had some issues. What we didn't realize, or not everybody realized, is that most folks realize there are multiple ways that you can sort of generate regionality in a TIM. You can do a pathway, which is what you see And these are all pathway regionality. You can also do a polygon and you can do a circle. We actually did test all three of the different ways of doing it, but what we didn't realize was that regionality also has directionality built into it. You can set it up so that it works, along the path that you created, in reverse of the path you created, or both ways. What we didn't realize is that one of the sites had set it so that the pathway was set to both ways, but they were also using a bit field mask that specified only one direction for the TIM message. And what we found was that some devices actually applied the pathway directionality above the bit field mask. And what we also realized is if you're using a pathway, you don't really need to use the bit field mask at all because it already has the directionality built in. So again, something easy that we found that we can put some best practice around. But again, something interesting to find that the devices do sort of have a hierarchy, it seems like, in some cases, of directionality that they apply. The case where we had an older TIM and an updated TIM broadcasting at the same time, the devices really didn't seem to like that. They seemed to cycle between the two. You could actually, some of the teams brought up sort of like command line interface, and you could see it actually switching between the two messages rapidly. It didn't really, the device didn't seem to really figure out which one to apply over the other, so it just switched between the two of them. So that was an interesting finding. Again, I think something that we can put some guidance around. The message count turnover was another one that I mentioned. Again, message count only goes to 127. It's 0 to 127. So once you get to 127 and it rolls over, it goes back to 0. But 127 is higher than 0, and so most devices continue to display the 127 message, which again is logical. But I think we figured out, like, if you just increment the message ID by 1 and then you reset to 0, then it knows that it's a new message and it should be applied over the old message. So I think we can put some guidance around that. But interesting, anecdotally, I guess we heard that Caltrans does run into this issue. They do this for some of their key warnings. So hopefully I'll talk to them this week and hear a little bit more about that. Another interesting thing we found is that within TIM messages, there is a sign priority. It's from 0 to 7. It basically says everything should be 0, which is the lowest priority. And then if you want something that is actually really important, set it at a 7. So we tried that, but the devices pretty much just ignored the priority. If there were two messages that one had a higher priority than the other, it just displayed both, pretty much across most of the devices. So that was another interesting finding. It doesn't seem like many folks are using the sign priority. So again, we could probably do some best practices around that. And then the last one here was, the OPUs generally actually didn't display the speed limit warnings unless they were going above the speed limit. It took us a couple hours to figure that out. But it's actually a good thing, I think. That's actually in line with NHTSA's design guidance, which is to lessen the number of warnings to drivers. You don't want to overwhelm the driver with warnings. So if they're not going above the speed limit, you probably don't need to warn them about the speed limit, right? So I think that was a good finding, and that's something I think we actually want folks to continue to do. So those were the major sort of findings we found while we were doing the testing. Where right now the team is going back through and we're starting to get the data in from all the different teams, and so now we're going through and going to be looking at the more detailed data and the results that folks are sending us to create some more detailed outputs, and those will all be included in a test report that comes out here soon. One of the most exciting things, though, we did was some stretch goals. The first thing was a network V2X implementation. So for those that haven't been following us, this is a newer sort of set of terminology that you'll be seeing more from the DOT. But we have essentially direct V2X, which would be LTE V2X, new radio V2X. The side link PC5/DSRC direct technologies fall under direct V2X. And then network V2X is everything that goes through a different network to get to its endpoint, right? So cellular, unlicensed Wi-Fi, those types of technologies would fit into the network V2X. So we are doing some testing at Turner Fairbanks with some of the mobile network operators to sort of classify cellular performance across a number of different ITS use cases. And we had built a tool to help us test that with out at Turner Fairbanks. One of our subcontractors, New York Consulting, which is, for those of you that know Tony English, it's his company. They added on to that application this mapping capability. So what you're seeing here is it's a basic application running on either an Android or an iOS device, and it'll just pull up a map and it'll display the TIM message on the map exactly the same way as it would in the LTE V2X OBU. And as you traverse through the oval, it would trigger the signage down here, the exact same signage as you would get in LTE V2X OBU, working essentially exactly the same. And these were the same Uber encoded TIMs that we sent to the RSUs. Were sent to in this case, we were using Verizon's IMP service that they're working on. And so it was the exact same TIM messages sent RSU into the LTE V2X. And like I said, it worked just the same. Directionality worked the same. It looked essentially the same. I'm sure if we pull the performance logs, the latency is going to be higher, but in a TIM use case, it's probably not really relevant, honestly, for most cases, since these work zone and messages popped up, within milliseconds of entering where you're supposed to. So again, this was really cool. Really, sort of, in my opinion, the first demonstration of a cellular service operating very much like a traditional LTE or direct V2X service. So we were very excited about that. It's obviously very proof of concept still. Wasn't using SCMS certificates or anything like that. So it wasn't a perfect demonstration, but it showed a lot of the promise of cellular technology. And then the other thing we did was we did try and do some SCMS interoperability. We had an ISS enrolled device and an AutoCrypt enrolled device work together. However, we sort of had to kludge that one. We didn't have a production CTL, so we used the LCCF file. We modified it so that they would trust each other. So this wasn't really a production test. It was a good proof of concept, but we want to do it the real way with the CTL, with multiple SCMS providers in the future. So we're going to come back to this one for sure. But it was at least exciting to see more than and SCMS working together. So this one, like I said, still a lot of work to do, but again, it was exciting to at least see another device enrolled in the different SCMS provider operating. So again, these were really, this one was the really, really interesting one. Like I said, we primarily have worked with Verizon on this. However, it's really just the Verizon MEC that was involved in this. We actually had folks on AT&T, T-Mobile, and Verizon all hitting the same resource, and it worked the same for everybody. So it was interoperable across MNO providers. Again, if you looked into the details, you'd probably see latency differences. But again, I don't think it was super relevant to this effort. Any questions about that?
Yeah. So the path of the message is like, was an OBU involved in this case, or is it a cell modem in the vehicle?
This was somebody's cell phone. So
no, I mean, but how do you get the position of the vehicle?
So the Verizon.
Do you want me to answer this?
So the MEC is an MQTT server, and essentially you're laying out the TIM within this MQTT server, and so the device, the application that was created, just creates these little sort of pseudo BSMs. They're not actual BSMs, right? Because it's a cell phone and it doesn't have as much information to create a real BSM. So it creates sort of pseudo BSMs and sends that information to the IMP 10 times a second. And then it pulls from the IMP whatever information that the IMP has, They use like I think it's a geohash, right? System. So you have to be within so many geohashes of this the thing that you are interested in. But yeah, it's using this cloud service, and you're transmitting your position to the cloud service, and then it's telling you, okay, here's what's.
Oh, okay. So you're this doesn't have a SIM card in the OBU, for example.
No, this was we were running this on our cell phones and
So
things.
what? It's like Ryan and I were there. We loaded it both on our cell phone when we were in the same car. You can see the blue and the red car
Yeah.
virtually track itself, but then we got into separate cars and put some space between it, and you can see the individual cars come across on your app.
Yeah, if you're
Okay.
yeah if you look closely, that little red car is the person whose phone this is, and then the blue car is probably another person using the application in the same car as that person. so, so yeah, so you would see other folks on there. Obviously, we didn't. We're just using it primarily again to do performance testing of 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 the different MNOs services. Um, but so you don't really it won't do any of the like the V2V safety applications. But obviously we got Tim messages working with it. So that was the cool thing. And we've demoed it at Turner Fairbanks. I think we have the ability to do demos of it now there. So it's kind of a cool capability. Like I said though, it's still very early days, but again, I think shows the promise of what uh, interoperable LTE VDEX and cellular could look like. So what you'll see next for this event is we're in the process of getting the ESRA and test plan updated. That should probably be out in a few weeks, in which you'll see all the changes. We made quite a few changes to the testing when we got there and realized we could do things actually a lot faster than we had originally planned. We'll have the test results and the test report, and we'll also be posting the data. That'll probably be in the next month and a half. We're starting to develop a best practices for TIM deployment guide. I'm trying to pull in TIM guidance from others as well. I know some of the folks at the test, Rick Smith from Trihydro and some of the Connecting the West team, I think are pulling together their own sort of TIM deployment guidance. So we want to incorporate whatever we can from that. I know Nick Hagemeyer at Drive Ohio has some guidance around sort of traveler information messaging. And I've heard Caltrans stuff, so I'm going to reach out to them while they're here this week and see if I could get some of theirs. But we're going to be developing in that interoperability technical working group some best practices for the TIMs based off of what we learned. And then next month we want to start planning the next interoperability test event. So I'm interested in sort of the community telling me what they think is the most important things to test next. And specifically like deployers, right? I'm really interested in like what are the issues that deployers are encountering now, and we can help them fix and help the vendors fix. Because I actually got a lot of feedback from vendors after this, while we were planning this testing, telling me how much time they spend helping deployments work through TIM messaging and things like that. So we want to help if there's things like that that we can hit in an interoperability test, things that folks, in this room, vendors, testers are noticing are like, hey, these might be tricky areas for folks that we're seeing slightly different performance. Let me know. I'm happy to include it in the future interoperability tests. Sure.
Yeah, stat map and assured green plan.
Okay. Well, that's why I think the next event will probably be signal focused.
To lead up to that, the 472-page document that was just finishing balloting, we're going to have Ralph Morris, who's a traffic signal controller and the editor of a lot of this document. He'll be speaking here Wednesday at noon. We'll have Steve Van Sickle and Justin Manu give more of a technical presentation on Wednesday afternoon on the OBU spec that's coming out. So we're trying to bring this together. I was also there. I had a little bit different purpose than Justin. I actually had all my devices at the plug test certs. I wanted to, it was my first experience of dealing with production certs. And I wanted to see what the devices would do. Would the devices themselves look at these prototype certificates, and would they pass on the stuff or not pass on. Couple of devices was checking security. They saw the messages come in, but they did not send them out. So if you're kind of operating a test tool, you kind of want it to pass on both, but then give an indication you're not the correct cert and give you a failure flag versus just dropping it from a test tool perspective. So it was very pleasing on seeing one thing, Justin, that first day we ran all the RSUs at the same time.
Yeah.
That was an interesting effect, and decided that we only could do one RSU at a time going through the testing.
Yeah, we learned some interesting lessons from running the test. We had at one point like a rogue Tim was being broadcast from some device. We could never figure out what was sending this like lone Tim message that we didn't that was being broadcast by something. So that was interesting. But yeah, we definitely want feedback from the community on what we do next. We want to do that same thing for signal phase and timing and mapping, right? We want to pull in real deployments, have them generate maps, have them generate signal phase and timing with their signal controller configurations in an RSU configuration, and see how it reacts across multiple devices. And so what you'll see in the test report is sort of that information. We have the full layout of every RSU that was broadcasting the messages for each specific test run, as well as which OBU models were able to receive and brought in and display that message. So that'll be in the test plan. And then with that information, you should be able to also go through the test data and figure out which logs are applying to which data, and so you'll be able to see which TIM messages are being ingested. We also have all the TIM messages that were created in a JSON format that'll be part of the test data. So if you want to play around with the TIM messages that we've used, that'll be available to you. And moving forward, that is the plan for all of these tests. Is we do want to do everything in the open, publish publicly all of our results, and publish the data. And it sounds like that's useful for a lot of folks. So that is the future. Again, if you are interested in participating in the next interoperability test, I guess put a rough placeholder in the April-May timeframe, and that's where we'll go next. I will say I also have a separate SCMS contract that I'm hoping to kick off this year, hopefully to do some more specific SCMS testing. I would love to get into showing not just the CTL and all that, but then getting the SCMS community together to figure out how do we do misbehavior detection, how do you do certificate revocation across multiple SCMS providers. Like if I'm a microsec subscriber, how do I report an SASOL tech device that's misbehaving, and where do I send that report to, and how does that all work together? I don't know yet, but that's the stuff we need to work on. So that's a separate interoperability effort that hopefully will kick off this year. And so like I said, these type of technical things I think are sort of the key to really putting sort of an operational production shine on this technology. I'm a big believer in VDEX. I think it works, but I also think it needs a little bit of tweaking to work really well, right? And that's the type of stuff that we want to work out in these tests, right? Directionality doesn't seem like a big thing, but if you're encountering this technology for the first time, and the first time you see it, you're triggering a work zone warning, but the work zone is on the other side of the road. You're going to think that's kind of a janky technology, right? This isn't fully baked, right? So we want to give folks the right impression of our technology, and so that's really the goal of these tests, is to really flesh this out and make it look and work as well as it possibly can.
One of the key items is going to be the implementation and deployment of SLSS.
Yeah.
As far as interoperability, and there were some people at the Wyoming did not realize that they were broadcasting with it on, and of course you only see about 20 to 30% of those messages, even though they were broadcasting at 10 hertz. So that's something the whole community is going to need to be working on.
Yeah, and so that's one of the topics I want to tee up for this interoperability technical working group. I want to work through SLSS, that new v2x.xml configuration, and how do we roll that out, right, to deployments, especially right, like all of the deployments vendors have to be on the same config at the same time, right? So it's going to be an actual coordination process for most of these deployers. I want to work that process through the interoperability working group so that we have a process where, and maybe it's something where Omniair is checking the SLSS configs for all of these devices, and they give thumbs up for vendors when they've shown that they're interoperable with their SLSS configurations. And then we can give those reports to the deployers and say, hey, all of your vendors are now conformant with the SLSS. They've verified that it's interoperable. You guys can now deploy the updates for all of your devices and roll over to the new config, right? That's the type of thing I want to talk to in this working group, and that's another, I think, benefit to a working group like this is we can work through those types of things there. So that was the last of my slides, I think. Does anybody have any questions?
I know you said you're still working on the report, but are you going to be able to include some of the latency numbers from the network-based communication and things like that? Because I think folks are trying to figure out which air interface is appropriate for certain kinds of services,
right?
Things like that.
So
having some of that information would be useful.
yeah, what I need to see what we're able to capture from the IMP for this test. Like I said, though, we do have a specific test that we're doing at Turner Fairbanks that will have those latency numbers across multiple MNOs, across multiple use cases.
And especially, I was thinking also that if the MEC is affiliated with one particular MNO, then sometimes you might have a local breakout situation for that one MNO.
Right. So
it's not going to benefit the other.
Right. No. So the way we test the way we're testing it at Turner Fairbanks is we have multiple configurations, both with everybody, like, so if we're using Verizon, we would have Verizon hitting Verizon to another Verizon customer, Verizon hitting Verizon to T-Mobile, T-Mobile hitting T-Mobile to Verizon. We're doing all the different combinations of MNOs to see what the latency is across that as well. So we're trying to be very comprehensive in this, because I do understand that, like, folks are looking for this guidance of, like, what can I use cellular for, and it's interesting, and I just want to actually commend the MNO community. They've been actually very great working with us. We've been sharing information. Part of why I'm being a little bit hesitant to talk too much details is a lot of the MNOs, their stuff isn't considered commercial production ready yet. So they're a little bit sensitive about some of these numbers, and so we've actually been changing some of our testing to better facilitate actual detailed latency numbers, and they're actually making updates on their side as well, to improve performance. So and to be quite frank, the MECs are still being set up. Like, most of the time we've been testing with a MEC in Atlanta. We're in DC, so that's not really the edge. But they've set up. I think there's one in New York that we're working with now. They're working on setting one up in DC. So a lot of these things are still, like, this is still pretty much coming together, and that's what we're seeing. But we'll capture that in that report specifically.
And I think you can find any issues with coverage also.
Yeah, no, that's the other thing. That's the other part of this, right? Is, like, yeah, the coverage piece of it. Obviously, the cellular stuff only works if you have cellular coverage. If you don't have cellular coverage, it's not going to work. So, but there's going to be a lot more on that.
Have you checked end-to-end latency? Latency from.
Yes.
Right.
Yeah, we've been checking. Like I said, we've checked it from Verizon to Verizon, Verizon to T-Mobile, T-Mobile to Verizon, through their MECs, through just a regular AWS instance. We're testing a lot of different configurations, primarily because I think for some of these use cases, I don't think you need to use the MEC for something like travel information messaging. And the MEC does seem to provide lower latencies, but at the same time, I don't know that you need super low latencies for everything, right? There's a lot of use cases I think that might work just fine with a regular AWS instance, and that's a hell of a lot cheaper than these mech instances. The mech performance is a cost, right? So that's part of what we want to do with our testing is we want to lay out like what do you really need mech versus regular cloud services for, and what is what does that performance difference look like, and what is it appropriate for? Because I know state and locals don't have a lot of money to spend on these types of services, so
So just to follow up on that question,
Yeah.
what is the latency that you found between different areas versus just AWS?
I would say the majority is under 200 milliseconds end to end most of the time. But again, that's most of the time. It's not 99% of the time. It's most of it we're capturing in like 95%, right? Which again I think is great for things like travel information messaging, stuff like that. For safety, I don't know if I would want to leave my safety up to a 95% functional solution, right? So that's where I think we're really going to try and figure out like okay, like what is reliable enough for safety and what is not. And I don't think 95%. I don't even think 99% is probably reliable enough. You probably need like 3, 4, 5 nines. I don't know.
Or just different applications.
Right.
For really short range sub-seconds, you want direct radio.
Right.
But if you are doing a ping message, it could get there 10 minutes later. It wouldn't make that much
Right.
sense.
Exactly. And that's what we want to try and capture, right?
So do you believe that the network feed and apps is ready for standardization anytime soon? Because I assume that can't be a proprietary type scenario.
Well, I mean, I think, yeah, so I think if we can get the MNOs to come, and I've been, so for those that don't know, we have a next generation traffic management data dictionary standardization effort. That's really, for those that don't know about the old TMDD is center to center sharing, primarily TMC to TMC. With the next gen TMDD, we're actually looking at opening it up to third party interfaces as well, like things like Waves and others, right? We understand, that like, because the TMDD was 2 decades old, pretty much. People are getting a lot of information from third party sources. They're buying information. They're getting it from other commercial services. We wanted to be able to incorporate sort of those sorts of interfaces in the next gen TMDD, and I think that's sort of where some of this cellular stuff might fit, right? Because that's really truly just like a data interface, data transport type standard. It works just as fine for any sort of terrestrial networking as for wireless networking. So that's where I've been trying to push folks. I would love to see some standardization there. So I guess we'll see who wants to participate. Again, the USDOT doesn't mandate. My part of the USDOT doesn't mandate things, so it's all voluntary standards. But I think the testing that we did a couple weeks ago shows that there's the ability to make network V2X work like LTE V2X or similar enough that I think it's sort of transparent for the deployment community. Like personally, I would love to see it works so that a deployment agency just creates a TIM and then they deploy it in their Uber format to whatever services want to ingest it, right? Like if that's still cellular, if it's they push their RSUs, right? Like you should be able to get this information multiple ways. Some of the stuff, right? Especially TIM messages, things like probe data collection. There's a lot of those types of like less latency sensitive things that I think make a lot of sense for whatever communications technology is available is the one you should use. So, but that's part of what my program's trying to figure out and provide guidance on.
So there will be a test plan released in a couple of weeks, right?
The ASRun test plan for the one we did in Wyoming, yeah.
Yeah. So I wanted to ask if there's any plan that you use the CTLs like Delta.1 and operability test for SDNS.
Well, we wanted to do that. We couldn't do it. But we want to do that in the future. So yes, that is on our list of things to do. The .2.1 CTL functionality is definitely what we want.
So will it be like specified soon?
So I mean, I think part of it we need a CTL, right, to test with. So we got to work that out. We need, but I think the standardization pieces of it. We have a CTL format, right? We have a lot of what we need is documented in 16.2.1. We just need to pull everybody together in a way that we can make it all work together in a production type system. So I think that's part of my job is trying to figure out how to do that. But that's what we want to see.
You have a test and production TPL available. It exists. We just
Right.
need to get new vendors on the production.
Right.
production side.
Right. So that is something we want to do. And like I said, not probably not in a year. Unfortunately, I think this is probably multi-year. But I do want to do testing with misbehavior detection, certificate revocation, interoperability along those route lines as well. Right. I don't think you can have a system that grants trust without having a way to revoke trust, and and that's the part that I think we're still there's a lot of work left to be done there. So it's something I want to see, and it's part of my program. So we're going to try and make that happen, but I think that's a longer pole in the tent.
We want to be sensitive to the fact the SCMS manager requires certified devices to
Right.
issue production certs, but is there like a pro alpha type scenario where we can test it? Because I'm more concerned, like in test tools, if I don't have a HSM on my test tools, should I be using production certs
Right.
with that and compromise the system?
No. Right. Yeah. No. I
So
mean,
we have
that's
a little bit of a sensitivity.
right. Yeah. I think. Yeah. I definitely think for misbehavior detection testing and stuff like that, then we're probably got to do with test certs and stuff like that, right? Like I don't I'm not trying to revoke people's certs operationally if we don't have to, and I don't want to. I want to make it clear that the DOT does not want anybody breaking anybody else's security. So we are going to do it in a way that maintains the security of the system. But yeah, 1609.2.1 interoperability is something we very much want to see in the future.
In your short-term goal, is it like 2 SCMS providers? Is it like limited to 2
No.
providers?
It's a minimum of 2. So it's one of those things. For those that don't know, like we have to pick a number usually, and so like the minimum number for interoperability is 2. So they picked 2. I didn't get to the final numbers in that plan were not run by those of us that wrote it. Those are usually set a little bit higher up on the chain than us. But yeah, it's a minimum of 2. So if we can get more than 2, that's awesome. And I would love
like a requirement to.
So I will say that I believe the accelerator NOFO grants require the winning sites to use more than one SCMS provider. They don't specify anything more than that. So.
What for the like SCMS providers? Is there anything that we need to have to participate in that interoperability test?
Justin, you may want to explain. They really put this TIM interoperability together in like less than 6 to 8 weeks. So basically, they were scrambling to get as much in as possible. So they just ran short of time to add any more.
Yeah. So for folks that the interoperability test in Wyoming, we planned it from when we started planning it to when we executed it was less than 3 months, and it was really mostly because 2 reasons. One, we wanted to try and get it before the Wyoming CV pilots or around the time the Wyoming CV pilots ended because we knew they had some resources available to support. And secondly, weather gets real dicey after September in Wyoming, and so if we're going to do any testing in Wyoming, it had to be no later than the beginning of October because it can start snowing in September.
We got fortunate with weather.
Yeah, it was like 70 the whole time we were there, so we got really lucky. But yeah, for now, for the future, the next test will be like six months or more away. So much longer time frames for folks to be notified and participate. But yeah, it'll be open to. We'll probably set some minimum requirements, especially if it's an intersection related. So it'll probably be something around, and we'll work with Randy and company. Have you made it through? Are you this far into the certification process for your device or something like that, right? But as far as SCMS providers, as long as you can generate certs and provide them for our test, we're happy to have you. So.
Thank you very much, Mr. Justin, for your presentation. So I have kind of general question. So,
Sure.
Do you think we can tell how the policymaker would like to drive the society to be AV ready from this format?
Oh, AV ready. So, yeah, the stuff that we're focused on is really V2X. There is a separate automated program within the ITS JPO. My colleague Kim Jin Park runs that, so I'll put you in touch with him. He can tell you a little bit more about that. I will say that just from our office interfaces with NHTSA quite a bit on the work we do, and so I would say the NHTSA opinion is very much that V2X has its place, and that they're sort of still working through how V2X and automation, how they feel V2X and automation need to play together. So we're still our V2X automation research is still, I would say, fairly young, as we work through with NHTSA how they want that to sort of play out. I will say NHTSA is very specific about automation and how they handle automation, or how DOT handles automation. And so we're still working through some of how AV and V2X play, and how NHTSA will allow us to do research in that area. Any other questions?
Well, Justin, you've gone about an hour, so very impressive.
Thank
As
you.
many questions as you
Yeah,
have.
well, I'll be here through Thursday, so
Thursday? And you're going to talk again Thursday.
yeah, and I'm talking again Thursday morning. So if so at any point, please feel free to come up to me. Happy to chat about whatever.
Can we have a big applause for Justin?
Well, thanks everyone.
Thank you.